Okay, so in this lecture, we will discuss about efficient net architecture. So this efficient net architecture is introduced by the researchers by the Google Artificial Intelligence, Google AI, and this is designed for many challenging tasks, including object recognition, image segmentation, and in foreign language processes. So this is used instead of many other deep learning networks and deep learning techniques, so in order to reduce the computational efficiency and in order to increase the model performances. And so many traditional deep learning models come up with a trade-off between accuracy and resource consumption. If accuracy is more, the resource consumption will be more. If accuracy is less, the resource consumption is also sometimes it may be more. But this efficient network address this challenge by with the help of compound scaling. So this challenge will be addressed by this compound scaling. Okay, and so this compound scaling is done by the systematic scaling of model dimensions. The systematic scaling of the model dimensions, that is width, depth, and the resolutions in the sequenced manner. So this method allows the model to strike an optimal balance and make it adaptable for the computational budgets and hardware capabilities. And why we need this efficient net and what is mean by efficient net? The efficient net is nothing but the convolution neural network. That is also nothing but a CNNO. It is built on the compound scaling. So this scaling already we know this scaling is done systematically on the dimensions of width, depth, and the resolution of the model. So here we are discussing what is mean by width, depth of the resolutions of the model. Width scaling refers to the number of channels in each neural network. Width is nothing but the here width nothing but that is not a length, that is not a distance of any layers. So this is nothing but the number of channels present in the particular neural network. So by increasing the number of channels, so it uh, captures more complex patterns which are patterns features. So this may result in the accuracy. So if you are increasing the number of channels, that is if you are increasing the number of if you are increasing the width, so it will capture more complex features of the images or whatever the object. So this may help for the performance increases. Then depth is nothing but the total number of layers. So in here depth is nothing but the total number of layers presented in the network, or which total number of layers which we have used for the classification as well as the feature extraction presented in the network. So depending on the depth of the network, so the size of the network depends. The depth is increases, the size of the network will also increases. The depth will be less, then size as well as the parameters also decrease for the training. And the resolution. The resolution is in nothing but the adjusting the images input images size. So here in order to adjust, so we have to adjust the input size without losing any information present in the input, whatever input you will use. So that is a resolution. So this is in here in this slide we are showing that architecture of efficient net. So you are seeing clearly, right? So here this is input image and this is a convolution layer, that is 3 cross 3 convolution layer, then MB convolution layer. So this is MB convolution layer, that was mobile inverted bottleneck layer. So efficient net architecture mainly has a mobile inverted bottleneck layer as well as speed and excitation layers that has been used for the optimization to enhance the performances in the network. And this is a that is mobile inverted bottleneck layer. So continuously, so this is block 2 and this is block 1. There will be a total block 7 blocks. In all 7 blocks, it has the mobile inverted convolution layer or mobile inverted bottleneck layers. Okay. So and so here I am explaining everything here. So in mobile net, in mobile convolution layer is a fundamental building block of a EfficientNet. So we can say that the here we are seeing now in each block it is a MB convolution layer is a common layer. So that's why you can call it as a fundamental block for the EfficientNet architecture. The fundamental building block, and it is inspired by the inverted residual block which is present in the MobileNet. So previously we discussed about the MobileNet in the previous lecture. So in that MobileNet we have discussed about architecture, so and we are seeing about that is depth-wise separable and point-to-point separable. So same thing, that blocks will be, this is inspired by that blocks mobile depth-wise separable and convolutions layers, right? So that inverted residual blocks from the MobileNet. And the mobile this is MB convolution layer starts with depth-wise convolutions. So already we discussed what is meant by depth-wise convolutions and point-wise convolutions, and followed by the point-wise convolutions. Then in addition to this layer, and it in our this incorporates the squeeze and excitation layers in order to optimize the performance of the model. Okay, in order to optimize the performance of the model. And these layers allow the, so whatever layers we have discussed till now, that is MB layer and SE layer, these layers are allow the or increases the learning ability of the network, that is learning ability of the network with respect to channel wise, and these layers allow the learning ability uh, channel wise and dependency on create attention weights, so depending on the creation attention weights of the particular layer here. Then this efficient net comes with different variables. So this efficient net, like we have discussed in ResNet, right? So in ResNet and Inception version 1, Inception version 2, Inception version 3, like that. In ResNet 50, ResNet 18, ResNet 101, ResNet 50 version 2, version 1. So different variations are there. So even in mobile network also, there is mobile network version 1, mobile network version 2 is there. So in the similar way, in EfficientNet also we have different variations, that is EfficientNet B0, B1, B2, B3 up to B6 variations are there. Okay, so that we can study in the source which is presented here, roboflow.com. So you can study in detail, and here they have compare the efficiency of the EfficientNet with respect to other networks. So they are taken some examples as well. So you can go through with that website. So you can see that whatever they have explained there, and as well as you can see analytics vidya and many websites are there. You can go through that. So you can in detail you will learn what is meant by EfficientNet, what are the applications of EfficientNet, what are the different variations of EfficientNet. Okay, thank you.